This video is going to teach you how to do problems that involve the variables of pressure and temperature, which is known as Gay-Lussac's law. And again, the variables, the two that are changing are pressure, P, and temperature, T. The constants are the amount of gas in moles and the volume, V. Now, it's important that you remember that, again, just like in Charles' law, the temperature must be in kelvins. You will get the problem wrong if you try to solve anything involving Celsius degrees. So make sure you've always changed all your temperatures to Kelvin. Now, you can write an equation for these, which involves P divided by T equaling some constant K. And if you look at that, that's much like what we had for Charles' law. Gay-Lussac's law, like Charles' law, is a direct relationship. That means if T goes up or increases, then the pressure will go up as well. And you might have seen this in real life. If you think about, this is dangerous to do, and I'm sure you'll never do this, but if you take like an aerosol can or a pop can or something and you throw it into a fire, or it gets really hot, when the temperature goes up, that pressure increases and it'll explode. So to do the problems, it's very similar to everything you've done so far. In terms, I base these off of relationships rather than memorizing equations. So if you look at the example problem, you've got a sample of gas occupying 10 liters. Okay, 10 liters is our volume. It's at 114 torr pressure and 27 degrees Celsius temperature. I want you to calculate the pressure if the temperature is changed to 127 degrees while the volume stays constant. So the only two things changing are the pressure and the temperature. Now, if you look at the pressure, it was originally given as 114 torr. So you're going to write that in. And then the temperature, which was given as 27 degrees Celsius, cannot be recorded in Celsius. You're wise to change it right away to Kelvin. So 273 plus 27 is 300 Kelvin. And I'd get myself in the habit of writing only Kelvin temperatures in your chart so you don't make a stupid mistake later. Now, I want to calculate the pressure if the volume, or excuse me, if the temperature changes to 127 degrees, which if you add 273 to that becomes 400 Kelvin. Now, you look at what's happening in your relationship. The temperature is going up from 300 to 400. If temperature goes up, that means pressure must go up. So you're going to start with your pressure of 114 torr. And you're going to multiply by a fraction that makes that pressure increase. So you want to put the big number on top, or 400 over 300. And when you do that math, you should get a value of 152 torr. And now you should be ready, hopefully, to try the learning check, the practice problem that's below. Work it out first and then go ahead and answer your question online. Good luck.